All right, hey Ethan, happy birthday. I am making you a video for your geometry assignments for 3.4 and 3.5. We'll start on 3.4. This is on page 132 through 34. And you are responsible for problems 3 through 33, multiples of 3. All right, this is due on the 19th of January. So let's start with number 3. What you guys went over was distance and midpoint formula, parallel and perpendicular slopes. So we'll talk about those as we go through the problems. For number 3, they've given you 2 coordinates. And what we need to do to give the distance is use that distance formula that uses square root of x squared minus x2 minus x1 squared plus y2 minus y1 squared. So let's go ahead and we're going to label our coordinates here, x1, y1, x2, y2, and we'll plug them in under the formula. So x2 minus x1 squared plus y2 minus y1 squared gives us keep, change. 4 squared is 16 plus keep, change. 3 squared is 9. So we have the square root of 25. And the square root of 25, I just happen to know is 5. You probably know that too. So D is equal to 5. And that's your answer for number 6. For number 3, not number 6. Sorry, I've been making these videos for a while. Getting a little silly. Number 6. Same question. What is the distance between these coordinates? I've got 2 and -5, and -4, -8. Again, I'm going to label them. Don't forget, I'm not going to hesitate at all. I'm just going to plow through this, so make sure that you pause anytime you need to catch up, okay? All right, so let's fill in x2 minus x1, x2 minus x1 squared plus y2 minus y1 squared. Okay, parentheses first, so I'm subtracting, so I'll keep, change. Means I've got a -2 squared. A -6 squared. Plus, I'm subtracting again, so I'll keep, change. -3 plus, whoa, wrong words. -8 plus +5 leaves me with a -3 squared. Okay, don't forget that it is still -6 squared is going to be a +36, and a -3 squared will be a +9. Square root of 45. I don't believe that 45 is a perfect square root, but we could double check because I don't have them memorized. So I'll just punch it in there. It is not. So what we need to do with that 45 is find the prime factorization of it. We know 45, because it ends in 5, can be multiplied by 5, and that is 5 times 6, 5 times 7, and I think that's correct. Make sure I have that. 5, -4, -8. -4, +2. Okay, sorry about that. So again, we were here at 45 prime factorization. We need 5 times 9. Okay, so prime, remember a prime number, it means that its only factors are 1 in itself. So 9 has multiple factors, including 3 times 3, both of which are prime. So that gives me 3 times 3 times 5. Now when I'm dealing with the square root, any prime factors that are doubled get to go outside of the square root sign, and everything else goes back inside. So distance equals 3 square root of 5. That's number 6. Let's move on to number 9. This one wants the coordinates of the midpoint given the endpoint. So they're going to give you 2 coordinates, and they want to know where, if I wanted to go right in the middle, what coordinates would that be? So for 9, they've given you 0, 0, and 4, 8. The midpoint formula looks like x1 plus x2 divided over 2 and y1 plus y2 over 2. That's how we get each coordinate. So let's go ahead and we'll label these bad boys x1, y1, x2, y2, and then we'll just plug them in. So x1 plus x2, y1 plus y2 will give me 4 over 2, which is 2, 8 over 2, which is 4, and there's your midpoint. Takes us to number 12. Move down a little bit here. Same gig. They want the midpoint, so we're going to give them -1, -3, 12, -5. Right. So same x1, y1, x2, y2. So x1 plus x2 over 2, y1 plus y2 over 2. Give me 11 halves. And -8 over 2, which will give me 11 halves and a -4. Okay, so the book does show the answer here as 5.5, so you could do that also, but yeah, either way, you do have the same answer. So we've got 5.5 and -4, and that is our answer for number 12. So these are pretty simple. All you really need to do is label and then plug them into the correct formula. Let's move on to number 15. Now for this section, they want us to find the slope of the line through each pair of points. So if we are going to find the slope, we need to use the formula, slope formula. Oh, sorry. That one looks like, hold on a second, I have some notes I wrote. I'm just going to run them for myself here real quick. So M is y2 minus y1 over x2 minus x1. Okay. So we are going to find slope for number 15. For these coordinates, 0, 0, and 8, 2. Again, we're going to plug that into y2 minus y1 over x2 minus x1. So I just need to, I'm going to label these guys, x1, y1, x2, y2. Not everybody needs to label them, but I just find it's easier for me to make sure I'm using the correct number in the correct order. I don't want to get my problem wrong because I made a small mistake. That's a pretty easy, surefire way to make sure you don't. So y2 minus y1 over x2 minus x1 gives me 2 over 8. And I can reduce that, 2 going into 8 4 times, so 1 fourth is your slope. Number 18 looks like the same. They've given you 2, -6, and endpoint -4, -4. All right, let's look at that one. X1, Y1, X2, Y2. And again, we'll just plug those in. So Y2 minus Y1. Now remember, when you're writing these in, write your Y2, write your minus, and then write your next number, because a lot of times you might write the minus and then think it's already the negative and just put 4 minus 6. Okay, so really watch that mistake. Over X2 minus X1. All right, so for this one, I'm going to keep change, leaving me with a +2 over subtraction again. So I'm going to keep change, a -6. I can reduce that. 2 going into 6. 2 goes into itself once and into 6 3 times. And don't forget to carry over your negative sign, giving you a slope of -1/3. Okie dokie smoky. Let's look at number 21. Again, this assignment is 3 through 33 multiples of 3. Number 21 wants you to find the slope of each line. So what you have, let me get a sheet of graphing paper. Hopefully you're looking at number 21 in your book, but just in case. They have built a line through, it's kind of hard to tell. So it's definitely going to touch 1, 2, 3, 4 over, 1, 2, 3, 4 over, down 1. Okay, it's definitely going to touch here, it's going to touch here. Hang on one second, let me just replicate. 1, 2, 3, 4, and up 1, 2, 3, 4, and up 1. Okay, so let me draw this real quick. It's important that it be exact, because you're actually counting how much it's moved, and that is going to tell you your slope. So it looks like this. Now slope equals rise over run. So whatever your number is, if it was 2 over 4, it would mean you could go up 2 and then to the right 4, or down, whoops, can't see that, or down 2 and to the left 4. So assuming that this is my starting point, what I want to look at is where I started here to here. So I'm looking at a starting point here and the stopping point here. So I kind of went all the way across my graph. I'm looking for places that meet in the corner. So if I go here and say, okay, it didn't really, this, I can see it meets here, but it didn't in my picture. So I'm going to stay right here. Oops. Actually, let's do that in another color so we can see it. I'm going to say, okay, from here to here. And that's what I'm going to count. So from that point, so if I start here at the beginning and I'm going upward, first of all, I know that it's positive because it is, when I go from left to right, it is going up. So that is, I know my M is positive, okay? So I'm going to count from this point up to where I meet my last endpoint, and I'm going to go up 1, 2. So I know I have gone up 2, so there's my rise, and now I need to count my run. Over 1, 2, 3, 4, 5, 6, 7, 8. Of course, you know, you've been reducing for a long time, so the top does go into the bottom 4 times, and that is going to be your answer. That's an equal, by the way. So make sure, again, from left to right, it's going up, so it's a positive. And then we just counted from beginning point to end point. Don't look for little places, you know, in between, like this, you know. You want to find, boom, where it is on the actual grid. 21, okay, so that was number 21. Let's look at number 24. Okay, so this one looks like a lot of fun, not. Let me take a look at this one. Number 24. They've given you 3 parallel lines. Well, they look like they're parallel line. So they want you to use the slope formula or just the picture like that you have just done in order to decide if they are parallel. So when you're looking at these, they're going to look a little bit like this. So when they're on the grid, you're going to take a look at where this line stops right here, okay? And then it hits another line, let's say over here. So you are going to think of it like this. You're going to count this over, okay? And then you will go up, and then you'll count how many you go up, okay? All right, so this is my rise, and this is my run. So from here, I went over 2, and from here, I went up 5. Now, if I look at this line from left to right, here's the left side, here's the right side, right? It's leaning in this direction. It is a negative. Okay, and those are just simple as that. If it is going uphill, it's positive. If it's going downhill, it's negative. So that is a negative 5/2. So A is, this is letter A, so that one's 5/2. So you would do the same thing to B and to C. Let me change colors real quick. So on this one, you would do the same thing. You would say, oh, okay, well this one hits down here, from right here, and then it hits again to this section. So you would count this down, okay, and it ends up being 5, -5, and then it went over 2. So the slope for this one is also -5/2. Again, it's also going downhill. So we need to check on 3. When if it meets up here, and then it meets again down here, again we count all the way down and all the way over. When you look at this one really up close, this one goes down 9 and over 4. Okay, so this one had a slope of -9/4. So it did not match. However, for our answer, we can say that A and B are parallel, right? And that the slope was -5/2. Okay. Number 27. Wants us to look again at another graph, and they want us to tell them if the graph is perpendicular. Okay, so we need to find the slopes, and then we're going to say if they're perpendicular or not. So what we have is over 1, 2, 3, 4. 1, 2, 3, 4. On the -4, we'll have A, and then down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We see B. So here is A. Here's line A, and then B crosses right here at -5, -4. Okay, so on number 27, which is really odd because they didn't give us any answers on that. Hang on one second, let me just double check number 27. Okay, so for number 27, if you have okay, real quick, I'm sorry. Hopefully you had this explained to you before. Again, if your slope is going up, it's positive. If your slope is going downward, it's negative. Now, if it's horizontal, side to side, like this, it is 0. Slope is 0. Now, if it's going up and down, like this, in a vertical, it's undefined. So for this one, the slope of A is up and down, so we can say A equals undefined. B equals M equals 0, so there's no slope. So the question is, are they perpendicular? And they are. Perpendicular, when we use this symbol for, sorry, here we go. This symbol for perpendicular, what you want is a slope that is the opposite reciprocal. So if it was like 1/4, if it was parallel, the other line would be -4/1. So when you look at a slope that is undefined and a slope that is 0, sorry, let me see these. If it's one that's undefined and one that's 0, they complement each other. So we're going to say yes. So go ahead and make sure that this is your answer, and we can talk about these some more. So now for number 30, we're almost done with this one. On number 30, they're going to give us a pair of points, -2, 3, and 2, 4. They want us to find the distance. They want us to find the midpoint and the slope. That's a lot. Okay, so we're going to just jump in with our distance formula. So I'm going to plug in the distance formula, but normally you might have to write it, okay? So we're going to say D is equal to the absolute value, the square root of x2 minus x1. So here's x1, y1, x2, y2. x2 minus x1 squared plus y2 minus y1 squared. Okay, pull this in a little bit, and we'll keep going from there. All right, so a 2 minus -2, it's subtracting, so I'm going to keep change. That gives me 4 squared, which is 16, plus 4 minus 3, which is 1, and 1 squared is 1. So we end up with the absolute value of 17. Anytime we have an absolute value, we want to look for the prime factorization. However, the number 17 actually is prime. There are no numbers that we can break down 17 into, no numbers that multiply to equal 17. So distance is done. So we're done with that. Now let's find our midpoint. So we need x1 plus x2, x1 plus x2 over 2, and y1 plus y2 over 2. Okay, there's our coordinates. So these are actually going to end up being 0, 2. This will be 7/2. So 0 divided by 2 is a 0. We'll keep the 7/2, and there's midpoint. There's your second answer. Now they want us to find slope. Again, all of this is about having the correct formula and just plugging your coordinates into them. It's really not difficult at all. So slope formula is y2 minus y1 over x2 minus x1. 4 minus 3 is 1. These guys become 4, and their slope So those are you have 1, 2, 3 answers for number 30. Okay, last problem for this assignment is number 33. And it is, one second. God bless America. Okay, so